ASA stand for? Angle, side, angle. And what do you think angle, angles, or what do you think AAS stands for? Angle, angle, side. So here's what we got. We have this thing called angle, side, angle. And I'll draw this smaller into the box here as well. That just means you have two angles next to each other that are congruent to two angles that are next to each other in another triangle. And then the side has to be between the two angles. The side has to be between the two angles. It's called the included side. Like yesterday we had the included angle, now we have an included side. So that's what angle, side, angle looks like. We have angle, angles, or angle, side, angle. And then the other one was angle, angle, side. Let me show you that. What do you think the diagram's going to look like? What do you think the diagram's going to look like? Think about the tick marks that we've been using. What do you think it's going to wind up looking like? A triangle, yes, that's a good start. Okay. All right, so there's two of them. It says angle, angle, side, which means, what do you think? Take a guess. There'd be two angles, okay. Where's the side? Well, here's what I want to think about. Look at the lettering. Angle, angle, side, angle, side, angle. Where was the side for angle, side, angle? Between the two, right? Now it's not. It just has to be in the same position. So if I say angle, angle, side, angle, angle, side. Okay, that's what that would look like. So it's two angles and a non-included side. Now, could this side be here? Then this one would have to be there. Okay, it could go either direction of angle, angle, side, as long as it corresponds to it. It's just a matter, again, of following the tick marks. It's two angles and the side after it. Two angles and a side after it. It's basically what it looks like. You just have to follow your tick marks and it'll work. And last but not least, my hello again. Long time no see. I know we brought this up before. What three letters don't you see up there? Because there's no, you can say it, it's okay. There's no ass in math, correct. There's no ass in math. All right. So remember that. If you do write down ass, you're wrong. Okay? Just so you know. So let's just jump right to it. Actually, no, I want to skip this one. This one's not the one we want to look at here. I want to do this one. Yes. Okay. Okay. Take a second. Draw this one out. Label your vertices. And we'll walk through it and show how the progressions work. These are all straight progressions, again, just like we've done in the past. But the idea here, guys, is that as we're going through proofs for triangles, you have to remember that there's only 4 possible ways that you know right now. And it's really, 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 really important that you have a picture in front of you. So as you're going through it, you can write up and draw on the diagram to figure out what you're going to wind up with. hopefully you guys are starting to realize that the proofs themselves really aren't all that difficult because everything's on the progression sheet. Remember yesterday when we had even 12 total things you wrote down, at least 10 of them were either given or straight off the progression sheet. There really is not much thinking involved with this stuff if you follow your sheet and you read it. Really, it's kind of the idea. We're literally making this as easy as possible. Excuse me. I know, I apologize. So it's got a lot to it. Okay, let's see where we're at. What's the first thing you're going to write down? Your first given. My first given is angle CAB is congruent to angle DAE. What should I go do to my diagram? Mark it. You have to mark what you're writing down so that way you know where you're going to. Okay? So when I go mark that, I follow the letters to figure out the vertices. So it's CAB, so right here, and then it's DAE, which is also right there. There's my first angle. There's no definition to that. There's no progression, no nothing. It's just, hey, these are congruent. These I go to the next piece. The next piece says BA is congruent to EA. Again, it's given, which means I go to my diagram and mark it. No definitions, no progressions, no nothing off that. It's just, hey, applied. Here's some segments that are congruent. So I go to the next thing. The next thing says angle B and angle E are right angles. Well, that means there's something I can say. I believe somewhere on our sheet we have something about right angles. Right angles. All right. So if we have right angles, what do we know about right angles? Oh, right. The equal 90, correct. But what can we say? If I have right angles, what do we know about the two right angles? No. So here, since I'm given the right angles, according to your sheet, once you have that, you know that the right angle has to be congruent to the other right angle. Yeah, put it away. And the reason being, all right angles are congruent. It says so right there on your sheet. Which means, what do I have to put in my diagram? What's the symbol for right angles? That little square box, right? At angle B. Do you have congruent triangles then? How? That's not a way to, is that a way on here that says to prove triangles congruent? What is it? Done. Triangles are congruent. Remember, if it's not on this square of how to show triangles are congruent, you cannot use it. If it's not one of these, it's wrong. It has to be one of those. Okay? It has to be one of those. So go back again, like we were doing yesterday. There's a total of how many parts did we write down here? 10, right? Of the 10 pieces that were on there, 6 of them are given. 2 of them come right off of the progression sheet. That makes 8 out of the 10. 80% of the material in this proof is done for you. The next step about the triangle That's the 9th part of it. Literally 90% of this sheet, or of this proof, is on your sheet. 90%. All you had to be able to do is mark the diagrams, the right positions, the right spots, to figure out which of the methods you can prove. Which again, those pictures are on your progression sheet. There is absolutely zero reason to get any of this incorrect. All of the information is in front of you. 90% of this proof is done before you even have to think. Okay? Don't freak out with this stuff, guys. It really is that straightforward. Okay? So I know I crossed out a couple things to rewrite it, so I wanted to do a different progression versus something else. We haven't done an angle bisector in a while. So we have BD is perpendicular to AC, and BD bisects angle ABC. And then from there, we're going to prove that we have triangles ADB and triangle CDB. So we have perpendicular, which we have progression for. Angle bisector, which again we have progression for. Okay? A lot of stuff. We just got to find it on our sheets. No, we just did one. Oh, that one? I think I did click those, yes. Thank you. I get the stuff back to the line. Okay. Oops. Sorry. Forgot to move this. Shrink this up just so we have a little bit of space. Okay. BD, perpendicular AC. What does your progression say to do after you have perpendicular? You're right. You're on the right track. Oh, you're right from the first part. It says state the right angles that are formed. Yep, gotta do that first. So now if I'm looking at BD and AC being perpendicular, this is where we go to our diagram and we draw that little rectangular box so that we know which ones are which. Those two are my right angles. So I label them. Angle ADB and angle CDB, oops, are right angles. Given. Oh, I'm sorry. Definition of perpendicular. I was looking at the word given as I was writing it down. Now, after you state you have right angles, just like we did in the proof prior to this, we have to say what about those two right angles? Very, very good. They're congruent. All right angles congruent. Once I get through that progression of perpendicular, remember, when you have perpendicular, there are two things you have to say after it. First one, you have right angles. Second one, right angles are congruent. Right? Once you utilize all that information, you go to the next bit. The next one says that BD bisects angle ABC. So we write that down as our next given. BD bisects angle ABC. What does an angle bisector do according to your progression sheet? Angular congruency angle, which two angles are created that have to be congruent. If BD bisects ABC, well, in your picture, you start looking for it. Well, BD bisects the whole thing. That means these two guys have to be the same. You mark the diagram, and how many letters do you have to use to show that you have an angle? How many letters do you have to use to show for an angle? 3. So now I have angle ABD. And according to your progression sheet, that's your reason. You're following it verbatim. Those first 10 things you wrote down are right off the progression sheet. Everything, all the bits of information are on that sheet for that. Obviously, you have to figure out the lettering, but for the most part, if you can get through reading the sheet, you know where you're at. So now we have, back to our diagram. What do you have marked in the diagrams? We have 2 angles, right? Looking at that diagram, is there any way I can get an angle, or excuse me, a side between the angles, or a side after the angles? How am I going to say that it's between? Perfect. Very good. Again, on your progression sheet, there's a picture. I think we even used a picture exactly like this. Look for a shared side. What's the shared side here? BD. So BD is congruent to itself because of the what property? Do you have triangles that are congruent? By what? The side is between the angles, which means it's angle side angle. ADB. Oops. CDB, wasn't it? You are again using all of the information that is directly in front of you on that sheet of paper to do the proof. That sheet of paper is gold. Okay? Now, other classes don't use that sheet of paper. Don't know. Okay? Ladies and gentlemen, there's no reason for you not to ace all this stuff. You may scoff at that. Everything's on that sheet of paper. Everything's on that sheet of paper. Right? Everything's on there. I think I got one. I want you guys to do this one. Let's see where we're at. You're given BC and CD are congruent. BC congruent, CD. Mark your diagram. Angle B. Quick question: Why are they allowed to say just angle B, angle D in this case? No. Think about it. Why aren't they using 3 letters here? Okay. And in this case, because if you look at it, I can't say like angle C. Okay. I couldn't say angle C because there's so many different vertices that go through angle C. I could say angle B or angle D. Because in this case, there's just one angle that has that as a vertex. In the problem earlier, I think it said angle B and was it E were right angles. Those were the only possible angles they could have been. Okay, whereas sometimes you have to use the 3 letters. When we did the angle bisector, we used 3 letters all the time for that because it had to be. We have the perpendicular there. We had to use the 3 letters because there were counted vertices. Okay, that's why we have to use 3 letters most of the time. So you've got an angle and a side, which means you have to find an angle before that angle or an angle after that angle. So is there anything in this proof or anything in this diagram that I can infer from, like angles A and E? Can I say anything about? Why? Is there anything in there that says, anything from that diagram I can infer A and E versus 1 and 2? What are 1 and 2? Look at your sheet. Right in front of you. It's right there in front of you. What are angles 1 and 2? What's that? What do you mean? Yes, you would. But this case here, think of this as that bow tie. I'm only worried about those two because those are interior of the triangle. The other ones I don't care about because they're not anything. There's no reflexive sides here. There's nothing with the shared side. There's no reflexive sides here. There's no shared side. There's no such thing. Okay? Again, you just talked yourself out of the answer you gave me. Vertical angles. Then why are you talking yourself out of vertical angles? Yeah. Look at your progression sheet. You should have a picture that looks exactly like that. You should never get this wrong. I also drew one in that said that as also. Sometimes you have it drawn up like a bow tie. Yes, but does angle ACE make a triangle? Is it anywhere inside of a triangle? So we don't worry about it. That's why I was saying it's not inside of a triangle, so we don't do anything with it. Okay. So now, why do you have triangles that are congruent? Angle side angle here. Okay. Not SAS, it's angle side angle. If I'm not mistaken, I think I already put on the calendar which problems there. Let me look. I did not. Let me pull this up real quick and write it in here. It was angle side angle on that one. I forgot to put it on the calendar. I have it written down on my. This one here on page 232. I'm sorry, page. Not 232. It's on page 238. Want to do numbers 11, 12, 14, and 15. This is section 4.3. Okay. We'll do those, and tomorrow we're going to combine all of them together. And then we will have our short quiz on Thursday. What do you got? I'm trying to look something up. Make sure we got the right spot. No, what's up? I couldn't hear you. Yeah, it's just 4 proofs. 4 proofs just like we've been doing. 4 proofs, and then I think we got an additive quick questions from high school that she had. Yeah.